You now put your material into the chuck, and using the chuck key, you tighten the chuck. Onto your workpiece. Keep in mind you don't want the workpiece sticking out too far because then it will flex. So depending on how much you're cutting, you want the material sticking out enough in order to cut, but not too little because then you get too close with the cutter. And you tighten the work in the chuck. Remember, the number one rule is to make sure the chuck key is removed from the chuck before turning on the lathe. Because if you don't, the chuck key will fly out and may hit somebody or something. Every lathe is different, and for this lathe here, you need to make sure this is in the lathe position, and then here is the power on, power off buttons. And this controls the RPMs, the rotations per minute of the chuck. This is a Smithy combination mill lathe machine, but for this video we're going to be using it as a lathe, which is this portion here. A lathe is a machine that spins your workpiece, and you have a cutter here that then cuts it as it rotates. You can make different diameters along this workpiece. It also has a tailstock here that you can use either a chuck to drill holes in the end of your workpiece, or you can use a live center here, and this part spins against your workpiece to hold it a very long workpiece that you're trying to machine. So you can use the tailstock for different options. First step is loading your workpiece into the chuck. Slide it in the end. Use the chuck key to tighten. I hate this one. Use the chuck key to tighten the chuck around your workpiece. It's important to put the workpiece in the right position in the chuck. If you have your workpiece out here and you're machining, it will bend and you won't get a precision diameter. So if you're machining a short piece, you want the workpiece to be close to the chuck. If you're too close, you may hit the chuck with the cutter. This isn't good either. So depending on how much you're machining, decide how much of the workpiece sticks out of the chuck, and then tighten it. For the lathe, we use a lathe cutting bit. Most of them are triangular shaped and have a replaceable bit that when this tip goes dull, you can unscrew, rotate, and now you have a fresh tip to then machine with. This is held in a tool holder and placed, so you move this handle, slide it down, and then you can lock it in place. Keep in mind, you want the tool to contact the workpiece in the middle. And you can adjust this stop here to move the tool to the right height. You move the stop so that the cutting bit touches the workpiece. You want to move the tool so that the tip is closer to the workpiece than this edge if you're machining this face. And you want the tip closer to the workpiece than this edge if you're machining this face. And then you lock it down. Now we have to zero the digital readout. How we're going to do this is we're going to turn on the lathe, which will spin the workpiece towards the cutting bit. And then we're going to move the cutting bit towards the workpiece until it touches. And you'll know it touches by the sound, and you'll see maybe a little bit of chips flying. At that point, you can zero the x-axis. Then we'll move the workpiece out to this face and do the same thing. We'll rotate in and then 0 the y-axis, which is this direction. I'll now demonstrate. You now have the digital readout zeroed on this surface and this surface. You can now zero the x direction by pressing X, 0, X. You now can zero the y direction, y, 0, y. Keep in mind this digital readout has an option to change it to use with a mill. So this diameter light here means it's in lathe mode. So this y will be used as a diameter. You can press this to go absolute XY, or you press it and it's a diameter, which means when you cut in the Y direction, it's changing the diameter of the workpiece. So when you buy material, usually the face of this is not square. So we're going to face this side of the material first. Make sure when you're using the lathe, you wear safety glasses. I'll now demonstrate. We're now going to face the end of this workpiece. We do this by using this wheel here to move in the X direction, and this wheel here to move in the Y direction. So by using these two wheels, we can move the cutting piece to the position we want. So we want to cut off maybe 5 thou off this end here by moving to the digital readout 5 thou minus, and then moving this wheel while it's cutting until it cuts off the whole face. I'll now demonstrate. We now want to re-zero the X axis on the digital readout because now your material is in a new position. We're now going to machine down this diameter here to the diameter we want. Look at the drawing for the wheel to know what diameter you need to machine it to. Depends on what material you start out with. So I'm going to machine off material by moving in the Y direction, taking about at most 20 thousandths of an inch deep cut, and then move it in the X direction, machining off that material. Keep in mind, you don't want to go too far because your cutting bit would hit the chuck. I'll now demonstrate. If you start out with 1-inch material and you need to make the wheel 0.937 inches in diameter, then on this digital readout you need to keep cutting layers off until you have 63 thousandths, so 0.063 off the diameter. And you can check this with a caliper as you go. Let me demonstrate. Make sure if you're going to check it with calipers that you make sure you turn off the lathe. And then you can measure the diameter to check the size that you're at. 9.5. You want to make sure that you move the tool in the Y direction before moving back in the X direction so you don't scrape the part that you just machined. For the final pass, you want to speed up the lathe a little bit and move slower in the X direction. This will get you a nice, smooth surface finish. Check our diameter, 0.937. For the speeds, you can look at this chart here. Depending on the workpiece diameter and the material, you can see the RPM that you need to use. So we had 1 inch. We had plastic, but if you were aluminum, it would be 700 RPM. And then here, depth of cut. So the rough cuts, you can go up to 0.1. Finish cut, 5 thousandths. Gives you an idea of how much material to cut out on each pass. Now that we have our diameter for the wheels, we need to make a chamfer on this edge here. So we can rotate the tool bit so that this edge is at the angle that we wish to make the chamfer, and then tighten it down. Now when you turn on the lathe, you can move the tool bit into the workpiece and cut a chamfer on that edge. I'll now demonstrate. Now this edge has a nice chamfer on it. For the next step, you don't need this tool bit, so you need to remove it so you don't cut yourself on this sharp edge. You simply remove the lever and pull up. Put the tool holder aside. For the next step, we're going to use this chuck and put it in the tailstock. You just simply slide it in and it wedges into the end. You want to use a center drill to start drilling a hole in the end of your workpiece. You want to use a center drill to start the hole in your workpiece. So you put the center drill in the chuck, tighten it with the chuck key, and now you can move the tailstock with this wheel here. You now slide the tailstock to the position you want, and there's a handle on the back side that you clamp. So now the tailstock is nice and rigid. You then turn on the lathe and advance the tailstock into the workpiece. This will drill a hole into the end of the workpiece. You just want to go up into the middle of this chamfered section. This just starts the hole, and then you can use a drill bit to continue the hole. You can now take the correct drill bit, which if you look at the drawing is a 204, a number 6, and tighten it into the chuck. Line it up again, clamp down the tailstock so it's nice and rigid. Now you're going to drill a hole into your workpiece. You should go into the depth that you need to for the pieces you're going to cut off. You now move the tailstock up to your workpiece and lock it down so it's rigid. Be sure that it's retracted so you have room to extend the drill bit into the workpiece. And you drill into the workpiece as far as you need to for the pieces you're going to cut off. Keep in mind we're cutting plastic here. If we were cutting aluminum or steel, you'd need to be using cutting fluid. With plastic you don't need to, but with aluminum and steel you need to use cutting fluid as you do cuts. Now you remove the drill bit from the chuck. So now we can use this tailstock to make a counterbore using an end mill into the wheel. So put the 1/2 inch end mill in the chuck, tighten it. Now the drawing shows that it's a 1/2 inch counterbore, 0.13 deep. So what we can do, there's indicators here on the side of the tailstock, and we can set this up so it's right at one of the indicators and butt it up to the workpiece when it's not running. And now we know when we start cutting, we can look at this depth of how far the counterbore goes. So I'll turn on the lathe and bore it out to the correct depth. Now I'll demonstrate. Then slide the tailstock back. And we pretty much have a done wheel. Now we just need to cut it off. We'll use a parting tool for that step. So in order to cut off our wheel from this stock material, we're going to use a parting tool, which is a thin blade that cuts into the material and it breaks this part off. So we locate it on the tool post, making sure that this cutting surface is centered on the workpiece. And then this angle is loose, and so we want to line up the parting tool parallel to the part. So we can change that angle until it's parallel, and then tighten this nut. This will make a nice straight flat cut across the workpiece. We now need to zero this edge of the cutting tool. You can do this by turning on the lathe and then moving the tool bit to where it touches the part, zeroing it, and then moving the width of the cutting tool over and zero again. I'll now demonstrate. So I zeroed off of this face, but this is 63 thou wide, so I have to move over 63 thou. And then I zero again. So now my zero is on this side of the cutting blade, which is even with the side of the part. So now when I move over, the digital readout will tell me how thick of a piece I'm cutting off the workpiece. If you look at the drawing, it is 0.375 inches wide. So I set it to that dimension, and now I'll turn on the lathe and move in the Y direction until this wheel comes off. I'll demonstrate. Now we have a finished wheel. You just have to deburr these edges and hole. You can now follow these same steps to make the rest of the 3 wheels out of this material. But right now I'm going to show you how to disassemble the parts. So first you want to take off any tools you have. You now use the chuck key to take out the material. When you're done using the lathe, make sure you remove all the tools and put them away. And use a vacuum to clean up all the chips and wipe it down with a rag.